Greetings everyone, it's Fred Sweet. Welcome to Guitar Media's channel jumping video. Today we're going to be taking a look at this 1969 Gibson SG Custom, and we'll be playing the 1972 Marshall Model 1959 100 watt Super Lead. The speakers we'll be using will be the Celestion G12T75s and the JCM 900 cabinet. Our close microphone will be the Shure SM57, and the room microphone will be the Sennheiser E609. Please stay tuned. At the end of the video, we'll be going over channel jumping. Welcome to the channel jumping section of this video. Typically when we plug into channel 1, the high sensitivity input, we're working with volume 1, which is also referred to as the bright channel. Usually guitars with hotter pickups like humbuckers, Gibson guitars, P90s, this channel works better because it's thinner and it's just going to be more aggressive, and you're going to find a better response typically. The biggest difference between volume 1 and volume 2, or the bright channel and the normal channel, is on a lot of lead circuits we have a bright capacitor on volume 1, and this capacitor allows most of the signal to pass through pretty much as soon as you open up the volume to 2, 2.5, but it does not allow the bass frequencies to pass through. And as you increase the volume, this more or less phases out the bright capacitor, allowing the lower frequencies to pass through. And that's why typically I'll run this volume on 8 or 10, or in between 8 and 10, and a lot of times I'll run the bass up. And another thing that I've noticed is anytime I run it less than 8, I'm usually find myself rolling the treble and presence back to 2 or lower to sort of equalize and renormalize the frequency response, because if you don't, typically it can get very extremely thin and just not a well-balanced frequency response. When we jump from channel 1 to channel 2, what we experience is most of our audio is allowed to pass through the bright channel, or volume 1 or channel 1, as there is a lower sensitivity resistance on the high sensitivity input. There's a higher resistance on the low sensitivity input, and this is allowing less of the signal to pass through to the normal channel, or volume 2 or channel 2. And in a lead amplifier, the three biggest differences between volume 1 or the bright channel and volume 2 or the normal channel is the bright capacitor that we talked about earlier. There's also a tone capacitor, or a coupling capacitor, and that capacitor lies in between basically your signal goes in here to your first preamp tube, and then it comes out of the preamp tube through the tone capacitor that I'm talking about. And what that does is it allows only the DC line level current to pass through, and it eliminates any plate voltages or any other voltages from passing through to the volume control. And in this amplifier from the factory, it came with a lower value tone capacitor to voice the bright channel even brighter, which was a 0.002 microfarads capacitor. And typically we see a 0.02 capacitor, which is a much larger value, and your normal value in mustard capacitors. And looking in the amplifier, the first capacitor would be the normal channel or volume 2 tone capacitor, and then the second capacitor you see, going this way in the amp, would be your bright volume capacitor. And then the other main difference that we see is going to ground. You have to consider that the bright channel is one side of your preamp tube, and your ground capacitor is a 0.68 in a lead circuit. And what this means is the 0.68 increases mid-range and high frequencies and gain for volume 1 or the bright channel, whereas the ground capacitor on the other side of the tube for volume 2 and the normal channel is usually a much larger value, like a 220 ultrafarads or a 330 ultrafarads, which is increasing the bass frequencies greatly, amplifying the bass frequencies for the normal channel. And so those are the three things that decide the differences in voicings for the bright channel and the normal channel and a bass circuit. And so typically when we plug into channel 2, this channel is a lot more bass response and a lot more rounder, fuller sound. I find Fender guitars, Stratocasters, Telecasters, Jazzmasters, Jaguars, and any other really extremely thin tone type guitars, the frequencies seem to line up better in channel 2. And once again, when we jump from channel 2 to channel 1, we experience most of the signal being allowed to pass through channel 2 or the normal channel, and less of the signal being allowed to pass through to the bright channel, because there's a lower value resistance on the high sensitivity input of channel 2 and a higher resistance on the low sensitivity input of channel 2, and that's why less of the signal is allowed to pass through to the bright channel. So once again, your thinner guitars, this is a good way to jump, especially if you're looking to avoid squealing and microphonic tones coming from the guitar, but you still want sustain and response. This is a good technique. And then a lot of people actually, well, not a lot of people, but some people will Y-jack into the two high sensitivity inputs of channel 1 and channel 2, and what this does is it allows you to get the most possible gain from the amplifier, as now you're going into the high sensitivity inputs of both channels. And so people talk about experimenting with buffers and no buffers, and a buffer is just, it's something in your pedal that amplifies the signal to normalize the guitar cord plugged into the guitar, having another plug and another plug plugged out of the pedal into the amplifier. Typically you would be losing a small amount of signal, and the buffer or non-true bypass pedals are designed to correct that and equalize the amount of signal that is going into your amplifier. Thanks for watching, and check our channel for our latest videos.